This is the rest of practice 8.2, the ones that we didn't do in class today. What we were looking at was solving systems of equations using the method of substitution. And we said the first step that we need to think about doing when we're using this method is to solve one of the equations, it doesn't matter which one, for either x or y. Just a rule of thumb, a trick that we said would usually make it easiest on us is if we pick the variable that has a coefficient of 1, if we have one. That's going to help us reduce the chance that we have any fractions in our problem or anything like that, and a lot of times if we have fractions we'll make some type of mistake. So let's solve the top equation on number 5 for x. So that's our step 1, is to solve for x. Again, I just chose to solve for x because x has a coefficient of 1. So the equation x plus 5y equals 4. To solve that for x, we need to subtract 5y from both sides so that the 5y's subtract to give us 0. That results in x equals negative 5y plus 4. What this tells us then is that anytime we see an x in this system of equations, we can think of it as negative 5y plus 4. They're equal to each other. We can think of these as interchangeable parts. Anytime I see an x, I can substitute in what x is equal to. So our next step then is to substitute into the other equation, the one that we didn't solve for x, the value of x. X is negative 5y plus 4. So when we see x in that second equation, we want to take that out and substitute in negative 5y plus 4. So it is important that we put the expression in parentheses because we want to multiply that entire expression by the 3 and not just the first part of the expression. So once we're to this point, we're going to follow our rules for solving equations. We want to use the distributive property to get rid of parentheses, which is going to result with negative 15y plus 12 plus 15y equals negative 1. At that point, we see that we have some like terms on the left-hand side, so we'll combine those. Negative 15y plus 15y, these add together to give us 0. So that's going to result in 12 equals negative 1. Well, all of the variables canceled. We just have one constant equal to another constant that are not actually equal. So that tells us then on number 5 our solution is going to be, or our answer is going to be no solution. There is not a single ordered pair that would make both of these equations true. So if we were to graph those two lines, and again, graphing is a second method of solving these, if we were to graph these two lines, and I'm just sketching what this might look like, our lines would be parallel lines. So since parallel lines never intersect, they have no points in common, that tells us that there is not going to be a solution because they don't have any points in common. So looking at number 7, we need to follow that same process. First, we need to solve either the top equation or the bottom equation for x or for y. And we get to choose which one we want to solve for, x or y. Some people were confused because they said we've been solving for y all 9 weeks. Why are we now going to solve for x? Our goal is to not graph these equations. Our goal is to solve one of the equations for either x or y so that we can substitute what that variable is equal to into the other equation. So if it said graph an equation, then we would want to solve for y. But since we're just solving this system of equations by substitution, we want to be as smart as we can be in choosing a variable to solve for. So I see that the x in the first equation has a coefficient of 1, so that's probably going to be the easiest one to solve for. So I want to solve the top equation for x to begin. X plus 4y equals 8. To solve for x, we need to take the one step of subtracting 4y from both sides. That's going to result in x equals negative 4y plus 8. So like on the last problem, since x is equal to negative 4y plus 8, that tells us that these are interchangeable parts. I can substitute this expression in for x anytime I see x in this system of equations. So our next step is to substitute that expression in for x in the other equation, the one that we didn't solve for y, or for x on. So since I see 2 times x, I'm going to take the x out and substitute in what x is equal to. So that's going to be 2 times negative 4y plus 8 minus 5y equals 29. So distribute the 2, and that's going to result in negative 8y plus 16 minus 5y equals 29. At that point, we will combine like terms, giving us negative 13y plus 16 equals 29. Then we'll subtract 16 from both sides, and that will result in negative 13y equals 13. Our last step is to divide both sides by negative 13. So our y value comes out to be negative 1. So that's the first part of our solution. We have negative 1 for our y coordinate. Then we need to find the x coordinate. Well, once we know the y coordinate, it's not very difficult to find the x coordinate. We want to take one of the equations, either the first equation or the second equation, and substitute that value of y in for y in either the first equation or the second. So let's look at the first one. X plus 4y equals 8. Well, if y is equal to negative 1, then when we substitute in negative 1 for y, we'll end up with x plus 4 times negative 1 equals 8. So then we just need to solve that equation for x. So x minus 4 equals 8. We'll add 4 to the left and add 4 to the right, which gives us x equals 12. So our x coordinate of our solution is going to be 12. So our solution is going to be this ordered pair. So just to be sure we know again what this ordered pair tells us, this is the ordered pair that would make both equations true. If I substitute this value in for x and substitute this value in for y, these values should make the left-hand side of each equation equal the right-hand side. So let's try that. 12 plus negative 4 equals 8. So that works out. 24 plus 5 equals 29. So that works out. So this looks like a lot of work, and I told you all that from the beginning, but again, this is what's going to separate us from a lot of the places that might just teach one method for solving systems of equations. So this isn't complicated, it's just a lot of steps and is going to take a little bit of practice. So look at the next problem, number 8. Our goal is to solve one of the equations either for x or y. I'm going to, in this case, solve the top equation for y. Again, we could just as easily solve the bottom equation for x. So let's take 4x plus y equals 0, and I'm going to subtract 4x from both sides so that these subtract to give us 0. So y equals negative 4x plus 0, or I'm just going to leave it as negative 4x. So what that tells us then is that anytime we see a y in our system of equations, we can substitute negative 4x in for it. So with that being said, let's take the second equation, the one that we haven't dealt with yet. X plus 2y equals negative 7, and I want to put negative 4x in place of y. And what that's going to give us then is x plus 2 times negative 4x equals negative 7. Now we have an equation that instead of having x's and y's just has x's. If we have an equation that just has one variable, we can solve for that variable to find the value of it. So when we multiply, we end up with negative 8x. So x plus negative 8x, or we can just write that as x minus 8x equals negative 7. Well, x minus 8x is negative 7x. Divide both sides by negative 7, and we'll get that our x value is positive 1. So that's the first part of our answer. That's going to be the x coordinate of our ordered pair that these two lines have in common, or that make both equations true. Or we can think of it as the point where those two lines would cross each other if we graphed them. So our x coordinate is 1. Once we know our x coordinate, we still need to find our y coordinate, and we find our y coordinate by substituting 1 in place of x in either of the equations that we have in this problem. So let's use the bottom equation, x plus 2y equals negative 7. So if I take positive 1 and put it in place of x, what that's going to result in is 1 plus 2y equals negative 7. So we'll subtract 1 from both sides, giving us 2y equals negative 8. divide both sides by 2, and we end up with y equals -4. So this is the second part of our solution. And we'll write that in our ordered pair up here at the top. So the y value is going to be -4. Again, this is the ordered pair that should make both equations true. If we substitute this value in for x and this value in for y, it should make both equations, the left-hand side of each equation equal the right-hand side. So when we look at this, 4 times 1 is 4, plus -4 is 0. So 0 on the left, 0 on the right. When we put in 1 for x, 1 plus -8 equals -7. On the right, we have -7. All right, y'all, I hope this helps you.